Assalamualaikum warahmatullahi wabarakatuh, and very good all day. My name is Muhammad Andi Rifki bin Muhammad Azmi. My student ID is 2020898272. I'm from class EMD2 and 5A2. In this subject MEC 451, I will present the task that has been given to me regarding the problem 3.2, question number 12. A mass of 3 kg of saturated liquid vapor mixture of water is contained in a piston cylinder device at 160 kPa. Initially, 1 kg of the water is in the liquid phase and the rest is in the vapor phase. Heat is now transferred to the water, and the piston, which is resting on a set of stops, start moving when the pressure inside reach 500 kPa. Heat transfer continues until the total volume increase by 20%. So the question is, determine the initial and final temperatures, the mass of liquid water when the piston first start moving, and the work done during this process. Also show the process on the PV diagram. So based on this question, we can make an assumption, which is the process in this question in quasi-equilibrium. So the question has been given us the mass, which is equal to 3 kg, the pressure initial, which is 160 kPa, and the mass in liquid phase, which is equal to 1 kg, and the final pressure, which is 500 kPa, and it gives a state that the final volume is equal to 1.2 times volume 1, that is volume initial. So the question asks us to find the initial temperature. So the initial temperature is the saturation temperature at P1, when is equal to 160 kPa. So from table F5, there is no pressure at 160 kPa, but we have pressure at 150 and 175. So our pressure in this question is between that two values. So from the class that we have learned, we can use the interpolation calculation. So 160 is minus 150, divide 175 minus 150 is equal to temperature that we want to find, minus 111.35, divide by 116.04 minus 111.35. So from the calculation, we will get T1, that's equal to T saturation. T at saturation is equal to 113.3 Celsius. So from that, after that, the mass of water at vapor phase could be defined as the following, which is mass total is equal to mass at liquid phase plus mass at the vapor phase. So we rewrite the equation. We will get the mass at vapor phase is equal to mass total minus mass at liquid phase. So the mass total that have been given to us, which is equal to 3 kg, the mass at liquid phase also have been given to us, which is 1 kg. So from that we can find the mass vapor at vapor phase, which is 3 minus 1 is equal to 2 kg. So the mass at vapor phase is 2 kg. After that, we must find the saturated liquid specific volume. So we can find it at table A5, when the P pressure is equal to 160 kPa. So same as the before, we use the interpolation calculation, which is 160 minus 150 divided by 175 minus 150 is equal to specific liquid, saturated liquid specific volume that we want to find, minus 0.001053 divided by 0.001057 minus 0.001053. So from the calculation, from that calculation, we will get our saturated liquid specific volume at pressure equal to 160 kilopascal is 0.001054 meter cube over kilogram. So after that, we must also find the saturated vapor specific volume at pressure is equal 160 kilopascal. So same as before, we will use the interpolation calculation. We will get 160 minus 150 divided by 175 minus 150 is equal to our specific saturated vapor specific volume that we want to find, minus 1.1594 divided by 1.0037 minus 1.1594. So from that calculation, we will get our saturated vapor specific volume is 1.0915 meter cube over kilogram. So after we get the two values, we can find the initial volume of the water. So the initial volume of the water could be defined as the following. That is, initial volume is equal to mass at liquid phase times specific volume at liquid phase plus mass at vapor phase times specific volume at vapor phase. So we all of that terms, we have all the values, so just put it into the calculation, which is 1 times 0.001054 plus 2 times 1.0915. So we will get the answer is 2.184. So our initial volume is equal to 2.184 meter cube. So we can find the final volume. So the final volume could be defined as V2 is equal to 1.2 times V1 from the question, as mentioned in the question. So volume 2, the final volume, is equal to 1.2 times 2.184, which is the answer we will get 2.621 meter cube. So from that, we can find the specific volume for the final state. So the specific volume at the final state could be defined as the following, which is V2 that is final volume divided by mass total. So the calculation is 2.621 divide 3. So we will get the specific volume at the final state is 0.8736 meter cube over kilogram. So after we will get the specific volume, we will check the from the table A5 that it is defined that specific volume at the final state is larger than specific volume at vapor phase when the final pressure is equal to 500 kilopascal. So it is defined that it is undergoing the superheated process. So we want to find the final temperature. We will look at the table A6 for that is a table for superheated. So the final temperature could be defined from table A6. It at pressure is equivalent to 0.50 megapascal as the following. So same as before, we will use the interpolation calculation. So the final temperature that we want to find is minus 600 divided by 700 minus 600 is equal to 0.8736 minus 0.80509 divided by 0.89696 minus 0.80409. Sorry. So the final temperature we will get is equal to 675 Celsius. So that have answered the first question, that is to find the initial and the final temperature. So we will move to the next question, which is the question asks to find the mass at liquid phase when the piston start to move. So the piston start to move when the pressure is 500 kilopascal and the volume is equal to our initial volume, that is 2.184 meter cube. So we have the volume, initial volume, so we can find the specific volume at the beginning of the movement. So we will from the same as the before, we will calculate and get 0.728 meter cube over kilogram. That is our specific volume at the beginning of the movement. So we will we checking the phase at the intermediate state when the pressure is equal to 500 kilopascal. So the specific volume at the beginning of the movement is larger than specific volume at Faber phase when pressure is equal to 500 kilopascal. Hence, that means that the mass of the mass at liquid phase when the piston start to move is 0, because all the mass has been changed to vapor. That means there is no mass at the liquid phase. So that has answered our second question. So we will move to the final question, which is the total work done. So the total work done could be defined as the following, which is total work is equal to work when initial phase to the intermediate phase plus work when at the intermediate phase to the final phase. So the work at initial to intermediate phase is equal to 0 because there is no change in the volume. The volume is constant, just pressure, there is a change in the pressure, so it is equal to 0. There is no work done in there. So we will move to the second work done, that is from intermediate space to the final process. Intermediate process to the final process. So we will get the calculation is final pressure times the final volume minus the initial volume. So 500 times 2.621 minus 2.184. So from that we will get 218 kilojoules. Okay, so for that the PV diagram, as we can look here, the PV diagram is look at that when from one is the initial process to the intermediate process, from intermediate process to the final process. So that is how the PV diagram will look, and it's proof that all our calculation from above, from before, it is proof that as I told you before, when the work at initial process to the intermediate process is equal to 0, because the PV diagram we can look that the V is constant, only pressure, change in pressure, so there is no work, because work done is defined as when there is change in the volume. That's all for me. I hope that this presentation can provide more understanding in this subject in thermodynamic MEC 451. Thank you for watching. Goodbye.